Now let's talk about how SPIs work with lifecycle feedback. The SPI is a direct measurement of a claim failure. So you have some sort of claim, and you have some reasoning saying, well, I believe that claim X is always true. And the SPI's job is to say, well, you believed it was always true, but guess what? It's false now. There you are. Deal with it. So the SPI takes its own measurements and measures whether or not the claim is false in practice, as opposed to the nice theoretical world of the argument you presented. It's important to note that partial measurements are okay. An SPI need not determine every single possible way the claim can be false. It just needs to know at least one way the claim can be false. Because an SPI might be only a partial measurement of the claim, there are multiple SPIs for some claims. If there are 3 different ways that you can think of that the claim could be false and you can measure all 3, that's great. If there's a 4th way, well, that's a lost opportunity, but that still means there's some sort of value in measuring the 3 ways you can figure out how to measure. If you have a falsified safety case claim, in other words, your SPI says, hey, guess what? You thought this claim was true and it just got shown false by operational experience. It does not necessarily mean you're about to have a crash. It could be way down in the details and you could have a very, very subtle violation. For example, you could say, well, I have a false negative rate of less than 10%, just to pick up a number, and your false negative rate is 10.1%. Does that mean all of a sudden all your vehicles are going to crash tomorrow? Probably not, one hopes. But if you said it was less than 10 and it's not less than 10, then something's wrong with your safety case and you need to go figure out what's going on with it. It means the safety case has some defect. An SPI violation, by definition, means your safety case has a problem. The root cause analysis might reveal, well, there's a product or process defect. There's an invalid safety argument. Maybe you just got the safety case wrong. There may be an issue with supporting evidence. There might be an assumption error, and so on. It might be that you just change the threshold a little bit and everything's okay, but you can't just change the threshold to make the problem go away. You have to have some sort of reason that changing the threshold makes some sense. For example, maybe you increase one threshold but decrease another so the net risk stays the same, but now the system is operating closer to what you expected.